Hello, in this video I will go over the ratio test and when to use the ratio test. So this is Calculus 2 and we are going to go over ratio tests. So how do you know, well, so this is the ratio test, the summation of times a of n, and then defined by the limit as n approaches infinity of the absolute value of an plus 1 over an, absolute value equals the limit. So it's very important that you put this absolute value because if you don't, your value, uh, your limit value will be different. And if the limit is less than 1, the series converges absolutely. And if the limit is greater than 1, the series diverges. And if the limit is equal to 1, it is inconclusive. Just one very key note, always use the ratio test with factorials. So that's another big clue. When to use factorial test is when ratio test is when there is some kind of factorial. So let's do an example. Let me go over the steps. You just multiply n, replace n with n plus 1, and then you multiply the reciprocal of the original function, and then put in the absolute value. So let me show you. So example 1 says determine the convergence slash divergence of the summation where n is equal to 1 to infinity, and it's negative 10 raised to the n over 4 raised to the 2n plus 1 times n plus 1. So I know I'm going to use the ratio test because it is a ratio, right? It's a fraction. That's the big clue. So what I'm going to do first is I'm going to replace n. So wherever you see an n, replace n with n plus 1. Okay? And then once you do that, you're going to multiply the reciprocal of the original function. What do you mean? Here, I'll show you. Okay, I'm going to show you. So it's going to be the limit as n approaches infinity. And then step 1 is wherever you see, I'm going to put the absolute value, and wherever you see an n, replace it with n plus 1. So it's going to be negative 10 raised to the n plus 1 over 4. It was originally 4 raised to 2n plus 1. So wherever you see an n, replace it with n plus 1. So it's 2 times n plus 1 plus 1, and then times it by n plus 1. So it's going to be n plus 1 plus 1, right? And then over here, you're going to multiply it by the reciprocal of your original function. So your original was negative 10 raised to the n over 4 to the 2n plus 1 times n plus 1. So the reciprocal is just flipping the numerator into denominator, right? So the reciprocal would be 4 raised to the 2n plus 1 times n plus 1 over negative 10 raised to the n. And then don't forget the absolute value. That's very important. And then could we plug in our n for infinity? Not yet. What I could do is simplify this a bit more. So let me simplify this. So it's going to be the limit as n approaches infinity. And then if you recall, when you're raising power, you're technically multiplying. So for example, 5 raised to the x plus 3, that's the same thing as 5x times 5, 3, right? Something like that. So if you look at this term here, we have negative 10 raised to the n plus 1. That's equivalent to saying negative 10, negative 10 raised to the n times negative 10 raised to the power of 1. And then on the bottom, just FOIL this out. So 2n. So this would be 2n plus 2 plus 1. Wait, so this would be 2. When you FOIL out this 2, this is 2n plus 2 plus 1. So that's going to be 4 2n times 4 to the third, right? 2n plus 3, right? So this is going to be 4 raised to the 2n times 4 to the 3. And then over here, n plus 1 is n plus 2. This should be a minus. And then this is going to be times negative 10 raised to the n. Okay, over here, 4 raised to the 2n plus 1 is equivalent to saying 4 raised to the 2n times 4 raised to the 1. And then you have this n plus 1. Okay, so the goal is to cancel as much as you can and then plug in your infinity or know your horizontal asymptote, because this is a rational function, right? So what is the limit of a rational function? The horizontal asymptote. So what do you see that could cancel or are the same? Let's see. I see this negative 10 raised to n is the same. What else? This 4 raised to the 2n is the same thing as 4 raised to the 2n. This is practically the same. And what else? Yeah. So when you cancel everything out, you're left with n plus 1. I think these cancels. So now you're left with the limit as n approaches infinity of the absolute value. So you're left with negative 10 times n plus 1 over, what else? Oh, no, this doesn't cancel. This is one of the fours cancels here. This is going to be 2. So 4 squared is 16, sorry, times n plus 2, absolute value. So if you recall, taking an absolute value turns anything to a negative to a positive. Remember, if you took the absolute value -5, it becomes a +5. So now what happens is I see a negative 10 here, so now that becomes positive. So now really it's just the limit as n approaches infinity. Now I'm going to get rid of the absolute value because the absolute value in -10 is +10 times it by n plus 1 over 16 times n plus 2. Okay. And then FOIL out this 10, so it's going to be 10n. Remember, we only care about the highest power in the numerator and denominator because that's how you take the limit of a horizontal rational function. So even though I could FOIL out the 10 times 1, I don't really care about this 10 because I only care about the highest power. So this is 10 to the n. And then if I FOIL out the 16, this is 16n. See how the degrees are the same? So the limit, or the horizontal asymptote, horizontal is the same thing as their limit, as n approaches infinity, would be y equals, because the degrees are the same, you use the coefficient, so 10/16, which can be reduced by 2. So that would be 10 divided by 2 is 5, 16 divided by 2 is 8, which is still 5/8, which is still less than 1. So they say that if it's less than 1, it absolutely converges. So our limit is going to be absolute converges. Let's do another example. Yeah, let's move on to example 2. Example 2 says determine the convergence/divergence, where the summation starts at n equals 0 from infinity, and then we have n factorial over 5n. So what I'm going to do is, first step is replace n with n plus 1. Okay. The second step is you're going to multiply top and bottom by the reciprocal of the original function. Okay, so, and then don't forget to put your absolute value sign. So for VC n, replace it with n plus 1. So it's going to be n plus 1 factorial. And then on the bottom, it was 5 raised to the n. So now that's going to be 5 raised to the n plus 1. And then you're going to times it by your original function's reciprocal. So your original was n factorial over 5n. So the reciprocal of that will be 5n raised to the n factorial. And don't forget to close it with absolute value. So we're dealing with absolute value, so we know we have to, if you're dealing with absolute value, we know for a fact we're going to use the ratio test. If you recall, n factorial is the same thing as n times n minus 1 times n minus 2, right? You keep on going 3, 2, 1. And then n plus 1 factorial is equivalent to saying n plus 1 times it by n times it by n minus 1 times by 3 times 2 times 1. Okay. So what happens is this becomes what happens is when you expand the factorial, you're going to get this. So remember, n factorial is n times n minus 1 times n minus 2, and then n plus 1 factorial is n plus 1 times n minus 1. So if you can continue, what happens is here, let me show you. So now you get the limit as n approaches infinity. And let me just, it would be parentheses n plus 1 factorial times it by 5n. And then on the bottom, remember 5 raised to the n plus 1 is equivalent to saying 5n times 5 to the 1. And then you have this n factorial. And what eventually happens is the 5n cancels. And then this n factorial cancels. So, and then this factorial disappears. So now you're left with the limit as n approaches infinity, n plus 1 over 5. And when you plug in your n for infinity, infinity plus 1 is infinity over 5, which is infinity, which is greater than 1. And we said that if anything's greater than 1, it diverges. Okay, let's move on to example 3. Example 3 says determine the convergence slash divergence. And we have the summation from n equals 2 to infinity of n squared over 2n parentheses 2n minus 1. I just do this one. I think I just did this one. Yeah, I just did example 3. Oh no, I didn't. Sorry. I get them confused. So this is example 3. I did not do example 3. I thought I did. Okay, so determine the convergence slash divergence of the summation from n equals 2 to infinity of n squared parentheses 2n minus 1 infinity. So step 1 is replace n with n plus 1. And then step 2 is multiply top and bottom by the reciprocal. So where we see n plus, replace it with n plus 1. So it's going to be the absolute value of parentheses n plus 1 squared over 2 times n plus 1. And then you have this extra minus 1 and then factorial times it by the reciprocal of the original function. So it's going to be the reciprocal of that would be 2n minus 1 factorial over n squared. Okay, and then clean it up a bit. So we're dealing with factorial, so we know that n factorial is the same thing as n times n minus 1 times n minus 2. And then 2n factorial is the same thing as 2n times 2n minus 1 times 2n minus 2. And then 2n plus 1 factorial is the same thing as 2n plus 1 times 2n times 2n minus 1, etc. Right, until you get to 1. So when you clean this up, it's going to give you the limit as n approaches infinity. And then we have n plus 1 squared wait, so you get n plus 1 squared times 2 minus 1 factorial over 2n plus 1 factorial times n squared. Okay, and when you simplify that, you get what do you see that cancels? So when you simplify this, when you expand the factorials, you're left with the limit as n approaches infinity of n plus 1 square. I mean, yes, square. And then you have 2n plus 1 times 2n times n squared. And we do. So there's no negatives, so that's good. So what you could do is just find your horizontal asymptote. Now you do have to do foiling, but you don't have to FOIL everything. You just have to FOIL the highest term. So starting with the numerator, what's n plus 1 square? That is really the first term would be n square, and I don't care about the other because it's not the highest power, right? Now on the bottom, let's see. I think the bottom power is going to be higher than the top, so it's going to be bottom heavy, right? So 2n times 2n, that's 2n squared, and then you have this extra n squared. So that's 2n to the fourth. And I guess the degree on the bottom is top bottom heavy. So remember the horizontal asymptote rules. If it's bottom heavy, or the degree on the bottom is bigger than top, the horizontal asymptote is going to be 0. Okay, so when they say if it equals to 0, it absolutely converges. Okay, let's do one last example of this rational test. Example 4. Determine the convergence / divergence. We have the summation from n equals 1 to infinity of 9 raised to the n over negative 2 raised to the n plus 1 times n. So we know the rules. You replace n with n plus 1. and multiply top and bottom by the conjugate. So you can just start writing it out. So the limit as n approaches infinity, wherever you see an n, replace it with n plus 1. So it's 9 raised to the n plus 1 over -2. And then you can kind of do this in your head. You have an n here. So n plus 1, that n becomes n plus 1. Then you have this extra 1. So that's n plus 2. It's going to be n plus 2. And then you have this n here. So that's going to be n plus 1 times the reciprocal of this is -2 raised to the n plus 1 times it by n over 9n. We get the absolute value. Let's see, can we simplify this a bit? Yeah. So over here, 9 raised to the n plus 1 is the same thing as 9n times 9, 1 times -2. -2 raised to the n plus 1 is the same thing as -2 raised to the n times -2 to the 1. And you have this extra n. Over here, -2 raised to the n plus 1, that's the same thing as -2 raised to the n times -2 raised to the 2 times it by n plus 1 times it by 9n. And then hopefully something cancels. Let's see which stuff does cancel. You have the 9n. That's -2n. And and then this -2 cancels, and then now this becomes 1. And when you put it all together, this is what you get. The limit as n approaches infinity of the absolute value of 9n. And then you're left on the bottom, you're left with the n plus 1 and the -2. So that's -2 times n plus 1. If you recall, we're dealing with absolute value. So now this -2 becomes a +2. So you can rewrite this as the limit as n approaches infinity. And then instead of absolute value, you can use parentheses. So it's 9n over, and then this -2, because of the absolute value, becomes +2 times n plus 1. Okay. So now this becomes 9n, and then on the bottom it's 2n, and the degrees are the same. So when the degrees are the same, you use the coefficient 9/2, which is technically greater than 1. So we can say it diverges. Okay. So yeah, that is the ratio test. And the next test would be the root test. Okay, I'm going to stop here.